Good morning, good afternoon. It is, Wednesday, April the 29th. And today we're going to be looking at review problem 9. We only have 10 review problems, so we're going to finish this up this Friday. Okay, so I will do a problem this Friday. Now, just a real quick announcement. And this announcement's really just going to Math 113. Your final has to be completed by next Friday, May the 8th. Okay? Now, that is via Gadsden State. Grades have to be posted by that Friday. Okay? I'm going to have you finish that by probably Thursday at noon. So May the 7th by noon, you're going to have to be finished with that final. And I may even change that some, but you're going to have to finish that final. It's just 10 problems because I have to go and put grades in the grade book. Or I have to put grades in for Gadsden State, and I have to do that. All my stuff's up at Sardis, so I'm going to go up to the high school and do that. So I can't have you finishing the test on Friday and then me rushing up there. I'm good with going, like if you're done at Thursday, I'm good going Thursday afternoon and working on it. That's fine, but I can't really. I can't do it on Friday, okay? It's just that would be too rushed in case something went wrong and I couldn't get in touch with anybody to complete it, okay? So anyways, but be looking for, I'll probably do a Google Meet with you guys. May just be 113. We'll do one probably this Sunday or so, but I'll get with you. All right, so anyways, to the problem. You have touched base on this. We have touched base on this before, okay? We have looked at these problems before. Now, I'm doing kind of some basics right here, okay? I'm going to show you what the graph of sine looks like, come back, show you what the graph of cosine looks like, and then we're going to talk about how some problems change, okay? So I'll probably have 3 problems here, okay? So this is going to be the graph of y equals sine, okay? Now, think about this. Think about your unit circle, okay? Think about your unit circle, all right? So what they do is we take the radian measures and we stretch them across the x-axis, okay? So remember, we got radians like pi over 2, pi, 3 pi over 2, 2 pi. And again, those are values. Remember, 2 pi is like what, 6.28, pi 3.14, pi over 2, 1.57. So you're going to see probably on the final that it won't be written as pi over 2 right here. It might be 1.5 or something. So that's going to be a little bit tricky, but I'll touch base on that in a minute. So let's talk about, okay, what is sine? How do we graph sine theta? Think about the unit circle. Okay, so if we think about the unit circle, when sine of theta, okay, so when theta is 0 radians, what is sine equivalent to? Okay, so when sine is 0 radians, so if I replace that theta, so I'm plugging in these values for theta. So when sine is 0, because here's 0, what is it equivalent to? Okay. And you go and you say, okay, 1, 0, it's the y value, so that's 0. Okay? So I put a dot right here. Okay? Now, think about this. Look on your unit circle. When sine is pi over 2, so where's that located? Straight up and down, right? Straight up and down. So when that is, so what is sine equal to then? It's the y value. Straight up, that's 0, 1, it's the y value, so it's 1, right? So it goes up to 1, right? How about when theta is equal to pi? So that's on the left-hand side, right? It's on the left-hand side. So what have we got again? It's negative 1, 0. It's the y value, so it's 0. Okay? What is when it's 3 pi over 2? All right? So that's at the very bottom, right? Not 270 degrees. What is sine equivalent to? Negative 1. Okay? And then at 2 pi all the way back around, again, 2 pi and 0 are exactly the same. That would be 0. So here is my graph, okay? We start here. We go up, down, there. And it's a wave, okay? It's a wave. Now, that graph continues on infinitely in both directions, okay? But all we're going to focus on is that one portion of it, okay? Excuse me, I'm sorry. Now, why we focus on that one portion is because that is what we call one cycle or one period, okay? Now, what I mean by that, that's where it started. See, it started at 0, right there, and then it goes up to a max, back down to an intercept, okay, down to a minimum, back up to an intercept. So it completes a full cycle of everything. Up to max, back to an intercept, down to a min, back to an intercept. So it's got intercepts, max, and minimums, okay? And that is what we call a complete cycle. Now, the thing that you're going to have to look at in a minute, okay, when I get to example 3, is why is the max 1, okay? Why does it go up to positive 1, down to negative 1? You know this. It's because of the number to the left of sine. Because I don't see 1, okay? So there's understood to be a 1. So the number to the left gives you your max and your min. That's your amplitude, we call it, okay? Now, why does it complete a full cycle at 2 pi? They always, sine and cosine, always complete a cycle at 2 pi. Okay, always. How does that change? Okay, that changes if there's a number in between the word sine and our angle theta. Okay, and I'll talk to you on example 3 of how we do that. Okay, of how that changes the problem. Okay. So anyways, but for this problem, this is what it always looks like, and this is how you look at it, okay? We'll get back, we'll look at example 2, which is going to be cosine theta. Alrighty, so now let's look at example 2, and we're going to do cosine theta here, okay? And I just want to show you, because on the test, there's going to be a problem that says, okay, what is this the graph of? That's what the test is going to say. What is this a graph of? It's going to show you a graph, and then it's going to have 4 options. Y equals sine whatever, y equals cosine whatever, okay? And these can be manipulated, right? So that's what we're going to have to be able to see and describe, okay? So I just want you to see the basics, and then that way you can recognize, okay, well, it can't be sine, so it's got to be cosine. Or it can't be cosine, so it's got to be sine, so I've got 2 choices now, okay? And then you'll be able to maybe hopefully figure it out from there. Now, as you recall in example 1, sine always starts at the origin, 0, 0, okay? Well, don't always, but y equals sine theta does. It's at the origin, okay? So we're going to remember that. It's always at the origin. Cosine theta is not, okay? It starts at a max, so to speak, okay? And here's how you think of it, or here's how it's just that unit circle stretched out, right? So I've got cosine theta, okay? So when cosine is 0, cosine is represented by what values? The x value. So look at cosine 0, or 2 pi, it doesn't matter. And you go over, and that's what? The 0.10, okay? So it always starts at the max. And the max is 1 Why? Because there's no number to the left of that. So then at pi over 2, okay? At pi over 2, remember, that now is at pi over 2, that's 0. Okay? And then at pi, it's -1. At 3 pi over 2, it is 0 again. Y-axis, right? And then at 2 pi, it's back to its max. So again, I have created a full cycle or a period because it starts at a max, goes to an intercept, down to a minimum, back to an intercept, up to a max. So I have touched base on everything. Max, intercept, min, intercept, max. That is a full cycle. And remember, that would continue on infinitely in both directions. Okay? Again, these are not at points, these are smooth curves. Okay? So, a way that I would look at these, or a way that I would think about these, is if I'm taking the test or I'm looking at a problem and it starts at the origin, I'm going to say, hey, that cat's sine. Okay? That's sine, period. End of story. If it starts at a max, say, hey, that's cosine. Okay? Now, that's, not the best rule of thumb, so to speak, but for what we're doing and for some of the basics and some of the stuff that we're looking at, that is always the way to look at it, okay? Or that is the way to look at it. Again, a period is completed at 2 pi, okay? If there's not pi, it's written at 6.28, okay? Why? Because there's no number in between the words cosine and the angle theta. If there was a 2 there, it would change it. And that's what we're going to look at next, okay? So I'm going to try to make these, as simple as I can, and but yet you still be able to understand it, okay? So when I get back, we'll look at example 3. All right, so here is example 3, and here is the one that you need to be able to do, okay? You need to either be able to recognize the graph or graph the graph or whatever, okay? But you need to be able to recognize this, and I'll explain this to you and make sure that you understand, okay, this is what we do. So there's 2 or 3 things you need to know, okay? The first thing I would think that you would need to know is, okay, is it sine or cosine? Okay, it's sine. So it starts where? At the origin. If it's cosine, it's going to start at a max. Okay. Not necessarily, but for the basics that we're doing, okay? So, but it's sine, so it starts at the origin. Okay, got that. All right. What's the amplitude? How high does this go? Look at the number to the left. Okay, so we need to know, is it sine or cosine? That's where it starts. Okay. Next, we need to know, what is the amplitude? The amplitude for this problem is what? Oh, there's a number out there. It's 2. Period. 2. So this graph goes up to 2. So if you're looking at a graph and it doesn't go up to 2, can't be it. Okay? Now, the third thing, and this will be the thing where they kind of mess with you some. Or not mess with you, but it's the more difficult part, is what is the period? Okay? Well, the period is always 2 pi unless there is a number between the word sine and theta, or in this case, x, okay? Don't worry about that. And yes, there is. There's a 2, okay? So we have got to find what our period is. We've got to find what our period is. We know our amplitude, we can look at it. But our period, we need to find it. And it's not bad. It's not hard to do. Here's what you do. There's a 2 there. So my period's going to be different. What's my period going to be? My period, make sure you can see, period will be take whatever this is, okay? In this case, it's 2x, okay? If it was 1/2 x, you'd take 1/2 x. In this case, it's 2x, so just take whatever is in between the word sine and the variable and write this down. So write down 2x. Okay, now what is it always equal to? 2 pi. Remember, our period is typically always 2 pi. So just take the number, the new number that's there, 2 in this case, or 1/2 or 3 or whatever it is, but in this case 2, and you take the 2x and you set it equal to 2 pi. Now you solve for x, or solve for theta, or whatever. So now we divide by 2, get x is equal to, those cancel, pi. So our period now is pi. So what this did, we talked about stretching and compressing a graph. When there's a number in between the word sign and our variable, okay, theta, x, whatever, it's a horizontal shift, okay, or it's a horizontal stretch or compression, okay, not a shift. So it's going to either stretch it or compress it. When that number is greater than 1, it is going to compress that. It's going to make the graph like at the beach. It's going to make the waves be rougher, right? It's going to make rougher waves. They're going to be coming in quicker. Where if it was a fraction, it would be more, it would stretch out those waves so they'd be longer like a lake, okay? So that's what we think of. So now, what typically happens in a range of 2 pi now happens in pi, okay? So what you have to think is, okay, we're going to go up to 2, because that's our amplitude, down to -2. Now, what typically happened at pi, at 2 pi, happens at pi. Okay? Now, I'm just going to divide this, I'm going to divide pi into 4s, okay? Because we're going to always have like 4 things here. So this would be what? Pi over 2 here. This would be pi over 4. This would be 3 pi over 4. Okay? Just like that. Okay? So we divide it into 4s. Okay? A 4th plus a 4th is a half plus a 4th is 3/4, so on and so forth, okay? So I divided it up like that. So that's kind of the issue that sometimes you're like, I don't see how you did that. I don't understand. I just took pi, which was our period, divided it by 4, and that's how I got my critical points. But those critical points are not critical points, but that's how I did my x-axis. Those are not necessarily that they're important, but you can do it slightly different, okay? You got to know that the period occurs at pi. If you know that, you can do the problem. These rest of these values aren't totally, they're not crazily important. If you know the amplitude is 2 and the period is pi, you got it, okay? You just got to be able to pick out the graph. So here's what we do. It's sine, so it starts at 0. It's going to do what? It's going to go up to a max. So that max is going to be here. It's going to go to an intercept. It's going to go down to a minimum. It's going to end where it began at an intercept, or at 0. So that graph, pardon my terrible drawing, but it looks like that, right? That's what it looks like. And that is a cycle, okay? That's what it looks like. So your job is to make sure you know the amplitude and you know the period. Now, you're probably not going to see the x-axis labeled like pi over 4 or pi over 2, okay? You're probably going to see it as a decimal, okay? So the decimals could be 0.5. It could go 0.5, 1, 1.5, 2, 2.5, so on and so forth. But know that, look, guys, pi, this right here, this is just like 3.14, right? This is like 1.57. This is like, I don't know, I can't do it in my head, but 3 times 3.14 divided by 4, okay? It's in between those, okay? So just be, If you know these three things, you're going to give yourself an outstanding chance to be successful on this problem on the test. Sine starts at the origin, cosine starts at the max, okay? If it's sine, okay, it's going to start at the origin. Bam, got it, okay? What's the amplitude? Number to the left, okay? If it's 2, it goes up to 2, down to 2, got it. And then know what the period is. Take that number in between the word cosine and the variable, or sine of the variable, set that equal to 2 pi, always solve. That's going to tell you where the graph ends. It don't end, but that's where the period, that's where one period occurs, okay, one cycle. If you know those three things, okay, then you're fine, okay? Then you're fine. And you should be able to pick those out, okay? All right, so I'm going to post an assignment. I haven't yet created it. I'm going to, try to see if I can insert some graphs and things of that nature. But like I said, just keep working these assignments. Make sure you understand them. And if you have any questions, comments, or concerns, please do not hesitate to reach out to me, okay? Hope everybody has a great day, and I'll post another video on Friday.